Hello students, next we are going to look into the hybrid parameter, also called as the H parameters. For H parameter, the equation is between V1 with respect to I1 and V2, as well as the current in the second port, which is I2 with respect to I1 and V2, and the values that connect them are H11, H12, H21 and H22. So it's the voltage applied at one end and the current that is obtained at the other end. It is this equation, this set of equation that are basically used. So now we know that for the matrix form, we can write this equation as V1 I2 is equal to H11, H12, H21, H22. Okay, and this is going to be I1 V2. Clear? So now if I1 is equal to 0, if I put I1 is equal to 0, if I1 equal to 0 means I am saying that this is open circuit and I am having the voltage source here plus minus V2. Okay, in that case the equation becomes then V1 is equal to H12 V2, or what we call it as H12 is equal to V1 by V2. Okay, when we have taken I1 is equal to 0, when we have taken I1 is equal to 0. This is basically called as, since we are taking it as open circuit, this is called as open circuit reverse voltage gain. Reverse voltage gain. Let me write reverse properly. So open circuit reverse voltage gain. Why we are calling it as reverse is because, as you can see, we are having voltage applied at the second port and getting the output V1 at the first port. So it is going from this direction to this direction. That's why it is reverse voltage gain. Whatever is the voltage you are giving here, how much voltage is coming here, that is what V1 when you apply V2. So V1 by V2 when I1 is 0 is H12, which is the reverse voltage gain, and from the second equation I will get I2 is equal to H22 V2. If I have put I1 is equal to 0, then I will get, or H22 is basically I2 divided by V2 by when I1 is equal to 0. So again this is going to be open circuit, but this is what? Current at the output port divided by voltage at the output port, which is current by voltage is admittance. So this is open circuit output impedance. This is open circuit output impedance. Okay, similarly, if I am going to take, if V2 is equal to 0, if V2 is equal to 0, then I will have first equation is V1 is equal to H11 I1, or H11 is going to be V1 divided by I1 when V2 is equal to 0. So how do you make V2 is equal to 0? By short circuiting, correct? We make it by short circuiting, and here is the voltage that we are keeping. There is some voltage, or you can say current source also, but right now I will draw it as a voltage. So if you are going to find out what is the current I1, then V1 divided by I1 is the input impedance, input side impedance. But when the other side is short circuited, isn't it? So this one I will call it as short circuit input impedance. This is short circuit input impedance. Okay, and then the last equation is, so the second one, I2 is equal to, if V2 is equal to 0, H21 I1. Therefore, H21 is given by I2 by I1 when V2 is equal to 0. So what we will call that? Again, that is going to be short circuit. But now I am trying to get I2 when I am having I1. So what is the current I2 flowing when I am giving I1 as the input? So it is basically current gain. And which direction? In the forward direction. So I will call it as short circuit forward current gain. Short circuit forward current gain. So these are the four. Now have a look. Have a look what the quantities are when I am talking about H11. Okay, if I am going to write H11, H12, H21, H22, then the first value is H11, it is input impedance, so it is ohms, whereas H12, this one is voltage gain. Voltage gain is having no unit. Okay, why? Because it is gain has no unit. Next, H12, if you would look here, sorry, here it is H12 is voltage gain, sorry. H21 was forward current gain. So here we are having again no unit. And the last one, H22, is output. This is not impedance, I'm sorry. This is admittance. This is admittance. Okay, please make that change. This is open circuit output impedance. So that admittance. So this is ohms. Sorry, mho. So this is the reason why it is called as hybrid parameter, and this you will see it in many transistor based circuit we will be doing mostly voltage at port 1 and current at port 2. So just as an example I will just show. See, generally whenever we do transistor analysis, this is the output side, this is the input side, suppose I am biasing it also. And this is VCC, and this side is going to be our input voltage. Okay, so if I consider this as a two-port network, then this much will come as a two-port network. And if you remember, I am basically trying to look into the fact of, if I am going to give a voltage here, how much of the current is flowing here, isn't it? How much of the current is flowing here? So I am basically interested in what is the voltage V1 and I2. That's why in transistor circuits you will find out that mostly it is the hybrid parameter that is used. It is mostly the hybrid parameter that is used. Anyway, that is not a point for our subject or our course right now, so we will leave it here, and then we will look at the condition for reciprocity as well as symmetry. So the condition of reciprocity, we have already seen this, that a two-port network is reciprocal if the ratio of excitation at one port to response at the other port is same if the excitation and response are interchanged, for with the equation we have already got here. All we have to do is we have to find out the left hand side and the right hand side. So I will, for left hand side of equation 1. Hmm? For left hand side of equation 1, that is I want to find V1 by I2 when V2 is equal to 0. So if I am going to put V2 is equal to 0, then what will I get? I will get equation, so I have to put it in equation number 2, that is 2a and 2b. So I will get V1 is equal to H11 I1 plus 0, and the second equation will be I2 is equal to H21 I1 plus 0. I want to take V1 and I2, V1 divided by I2. You can see these two equations are already V1 and I2. Therefore, the next step will be dividing them. Dividing them, we get, so dividing them we get, so I will divide V1 by I2, then I have put V2 is equal to 0 is the first equation, which is H11 I1 divided by H21 I1, where I1 and I1 will cancel off, and I will get this as H11 by H21. So this is my left hand side equation. Let me put that in a box, and this I will call it as equation number 3. Next, for RHS, for right hand side of equation 1, we have to put, what is equation 1? Yeah, we have to put V1 is equal to 0. So if I am going to put V1 is equal to 0, and I have to find V2 by I1. Okay, so put V1 is equal to 0 in equation 2a. So if I am going to put in 2a, V1 is equal to 0, I will get 0 is equal to H11 I1 plus H12 V2. So I1 and V2 are there, and that is what I want to find out in the right hand side, isn't it? V2 by I1. So from this equation, therefore I will get V2. So let me take it the other side for. So if I take one of them the other side, I will get minus H11 I1 is equal to H12 V2. Therefore V2 by I1, therefore V2 by I1 is, when I put V1 is equal to 0, V2 by I1 is going to be minus of H11 by H12, minus of H11 and H12, from which I can directly see, that I can directly compare it with equation 3. So this is my equation number 4. For reciprocity, that is equation number 1, the condition is that LHS should be equal to RHS, which is 3 is equal to 4, or, so now look, the denominator is this and the numerator is this. You can see numerator is H11, here it is minus H11, whereas the denominator is H12 and H21. So H21 should be minus of H12, okay, or H21 should be equal to minus H12. It should be the negative of H12. Therefore, so let me write it in a different color. For a network to be reciprocal, its H parameter should have or satisfy the condition that H21 is equal to minus H12. So whatever is there in H21, you should have a negative value of that. Hmm? So that means if suppose I am going to have a matrix in which I am having H11, H12, H21, H22, then what it says is that these should be having values which are equal but negative of each other, at opposite sign. Okay, next we will go to condition for symmetry. Again, condition for symmetry, the same statement we are using. For a network to be symmetrical, the voltage to current ratio at one port should be the same as the voltage to current ratio at the other port, with one of the port open circuited. So when I am going to put open circuited, the current is going to be 0, and that is what I am having here. Now from here, if I want to find out the H parameter, I have to first write for left hand side LHS of equation 1, put I2 is equal to 0. So if I put I2 is equal to 0 in equation 2, so both equations I am going to put. So I will get V1 is equal to H11 I1 plus H12 V2, and I2 is 0, and I am having H21 I1 plus H22 V2. Here H21 I1 and H22 V2. Now I am interested in V1 by I1. So if I am going to be interested in V1 by I1, I am having it in the first equation, but I have to avoid V2, for which I will look at equation second. So I will write this as 3b, and this I will write as 3a. Then I will write from 3b, I will get V2 is equal to minus of H21 I1 divided by H22. Okay, and putting it in and put it in equation 3a. If I put it in equation 3a, what will I get? I will get V1 is equal to H11 I1, and the second part will be H12 multiplied with V2. Now instead of V2, I will substitute this value, which is minus H21 divided by H22 into I1, or if I take I1 common, I will get H11 H22 minus of H21 into H12 divided by H22 into I1. Therefore, therefore V1 by I1, when I am considering I2 is equal to 0, is going to be H11 H22 minus H21 into H12 divided by H22. This is equation number 4. Okay, so I found out the left hand side. Next I have to find out the right hand side. So again, right hand side is V2 by I2 when I1 is equal to 0. So for RHS of equation 1, put I1 is equal to 0. So where I have to put I1 is equal to 0, I have to put in equation 2a and 2b. So put I1 is equal to 0 in look at equation 2b. Equation 2b has V2 and I2 is directly there, and I am having I1. If I make I1 is equal to 0, I will need to put only 2b. So put I1 is equal to 0 in 2b only. So when I put I1 is equal to 0 in 2b, I will get I2 is equal to 0 plus H22 V2, or V2 by I2 when I1 is equal to 0, V2 by I2 when I1 is equal to 0 is 1 divided by H22. This is my fifth equation. And now you can very clearly see from here that for symmetricity, so this is equation 5. For symmetricity, for the circuit to be symmetric, the condition is equation 4 should be equal to 5. Therefore, I will write it now in a different color. For a circuit to be symmetric, the condition for h parameter is that the numerator has to be 1. So that is h11 h21 minus h, sorry, this is 2 h21 h12 h12, and that should be put in a box. Okay, now have a look here. If I am going to have a h parameter h11 h12 h21 h22, so what is it saying? It's saying that this minus this, which is actually the determinant should be equal to 1. I forgot, yeah, the determinant should be equal to 1. So now let us write these results in the table that we have already made for so here for the h parameter. Once again, when we look at the equation for h parameter, you all will remember h parameter equation is the input current V1 is going to be related to h11 I1 plus h12 V2, and current I2 in the second port is going to be related to h21 I1 plus h22 V2. And the condition for reciprocity, we have already found out that it is that h21 should be equal to minus of h12. h21 should be minus of h. And let me again show where we had found that out. We had found that out here. Okay. So yeah. And the condition for symmetry was h11 into h22 minus h21 into h12 should be equal to 1, or the determinant of h should be equal to 1. Same was here, the determinant of the transmission parameter or T parameter should be equal to 1. Yesterday we had seen. So these are the 4 parameters that we have to remember, we have to study them, and based on that we will have certain results, and you can use this for finding out these answers for the two-port network, for the analysis of two-port network. Now we have to do another problem for h parameter that we will do next. Okay, thank you.